Hello everyone, this is John Hashmat and welcome to Physics Simply. In this video I will be solving the paper 2 exam for February-March 2025. So let's get started. Question 1 says the diagram shows three forces acting on an object. What is the magnitude of the resultant force acting on the object? So we have two horizontal forces here, 9 to the right, 1 to the left. That gives a resultant to the right of 8.0 newtons. And if we draw it head to tail, we have after that 6 newtons pointing vertically upwards. So if we look at this as head to tail addition, we connect from the starting point to the ending point to get the resultant force, which is the hypotenuse of this right angle triangle. So we can use Pythagoras, square root of 8 squared plus 6 squared to get the hypotenuse. That gives an answer of 10 newtons. Or we can say that the maximum value for the resultant of 8 and 6 is when 8 and 6 are in the same direction. That gives a total of 14. So 16 is not possible because the maximum here is 14, but this is not the case here since the forces are not parallel to each other, so it's not 14. And the minimum value for these forces is when the 8 and 6 are pointing opposite to each other. That gives an answer of 8 minus 6 to be 2 newtons. So it's not 2 either because the forces are not opposite in direction, so the only choice here left is B. Question 2 says which row defines speed and velocity. Speed is the distance traveled in a given direction or the distance traveled per unit time. It is a distance traveled per unit time. Velocity is the speed per unit time or the speed in a given direction. It is the speed in a given direction. So the answer here is B. Question 3 says the graph shows the journey for a motorcyclist. Which section of the graph shows the time when the motorcyclist is stationary at some traffic lights? Stationary means that the velocity or the speed is equal to 0, so we have C here. Question 4 says the acceleration of free fall on the moon has 1/6 of its value on Earth. On the Earth, an astronaut has a mass of 60 kilograms. Which row gives the mass and weight of the astronaut on Earth and on the moon? The mass does not change, so it is 60 kilograms on the moon also. And the weight is equal to mg. For the Earth, we have 60 multiplied by 9.8. That gives an answer of 590. And on the moon, it is 60 multiplied by 9.8 over 6. That is what is set at the top here. That gives an answer of 98 newtons. So the answer here is D. Question 5 says the load extension graph for a material is shown. Which point indicates the limit of proportionality? The limit of proportionality is the end of the straight line passing through the origin before the line gets curved. So B, C, and D are all after the curvature, so the only choice here is A. Question 6 says an object of mass 4 kilograms is moving with velocity 3 meters per second in a straight line. What is the momentum of the object? Momentum is equal to mass multiplied by velocity, so we multiply 4 by 3, which gives an answer of 12 kilograms meter per second. Question 7 says a tall cylinder is partly filled with two liquids which do not mix. The two liquids have different densities. A student measures the pressure due to the liquids at different depth. Which graph shows how the liquid pressure varies between positions P and Q? So from P, the depth increases, so the pressure should be increasing, not constant, so it's not D. And since we have different densities, because one liquid is floating over the other, as density increases, the pressure increases, so it is not a uniform change in pressure, so it's not C. Now for the greater density, the pressure increase would be greater. For the lower density, the pressure increase would be less. And P has the lower density because it is floating on top. So from P we have a small change in pressure, and to Q we have a great change in pressure since Q has the greater density at the bottom. So the answer here is B. Question 8 says a tennis ball with momentum 2.3 kilograms meter per second is struck by a tennis racket. The racket causes the direction of motion of the ball to reverse. The racket exerts an average force of 1,500 newtons during the impact with the ball. The racket and ball are in contact with each other for a time of 0.0024 seconds. What is the magnitude of the momentum of the ball as it leaves the tennis racket, the final momentum? We can use that the force is equal to the change in momentum over time, or force multiplied by time is equal to the change in momentum, which is final momentum minus initial momentum. Force is 1,500, time is 0.0024. The final momentum is the required here in the question. And the initial momentum would be in the opposite direction. So if we take the final momentum to be in the positive direction, the initial momentum, which is 2.3, should be negative 2.3 since it is in the opposite direction. So this is plus 2.3 in total. We get the final momentum by moving this to the other side with subtraction. So first we multiply 1500 times 0.0024 and we calculate the answer minus 2.3. That gives an answer of 1.3 kilogram meters per second. Question 9 says a car is traveling at speed of 8 meters per second. The kinetic energy stored in the car is 32,000 joules. What is the kinetic energy stored in the car when its speed increases to 16 meters per second? So kinetic energy is equal to half mv squared, half times the mass times speed squared, but we do not have the mass. We can calculate the mass by making it subject to formula, kinetic energy times 2 and then divided by 8 squared. Or we can say that the speed was multiplied by 2 from 8 to 16. If the speed is multiplied by 2 and the kinetic energy depends on the speed squared, so the kinetic energy should be multiplied by 2 squared. So 32,000 multiplied by 2 squared, which is 4. That gives an answer of 128,000 joules, which is approximately 130,000 joules. Question 10 says the sun is not the primary source of energy. For which source? It is the primary source for oil, wind, and waves, not tidal energy because it depends on the moon. So the answer here is B. Question 11 says an experiment is done to compare the rate of conduction of thermal energy in metal and plastic spoons. An ice cube is placed on one end of each spoon and the other end is heated gently. Which row has the correct prediction and the correct explanation? The ice cube would melt more quickly on the metal spoon or plastic, not the plastic, it is on the metal. And that is because metal is a good conductor, not plastic. So the answer here is A. Question 12 says 4 students determine the efficiency of 4 different electric devices. The teacher knows that one student has made a mistake in the calculation. Which value of efficiency is not correct? We have options 12%, 36%, 78%, and 102%. It cannot be 102% because the maximum efficiency is 100%. That is when there are no energy losses or no power losses. But if there are power losses or energy losses, it should be less than 100. It can never be more than 100%. Question 13 says a sample of gas is sealed inside a container of fixed volume. The temperature of the gas is increased. Which statement explains why the pressure of the gas increases? So temperature increases, the molecules move faster. The gas particles collide with the walls of the container more frequently. Yes, due to the faster motion. The mass of the particles increases. No. Number of particles increases. No. The time between collisions increases. No, it should be decreases because they are moving faster now. So the answer here is A. Question 14 says a student does an experiment to determine the specific heat capacity of a metal block. She records the following measurements. The energy supplied is 12 kilojoules in initial temperature 20 degrees, final temperature 45 degrees. Mass of the block is 600 grams. What is the specific heat capacity of the metal block? But the units here are all in joule per kilogram, not gram, degrees Celsius. So we should convert grams into kilograms. That would be 0.6. And then we use energy is equal to mass times specific heat capacity times change in temperature. So C is equal to Q over M delta theta. The energy is 12,000 for the kilojoules over the mass 0.6 multiplied by the change in temperature 45 minus 20. That gives an answer of 800 joules per kilogram degrees Celsius. So the answer is D. Question 15 says a metal block is left overnight in a cool, shady room. In the morning, the metal block is moved into warm surroundings, so the temperature increases. Which statement about the metal block is correct in the morning? The internal energy of the metal block increases. Yes, because the molecules gained energy. The temperature of the block decreases. No, the convection transfers energy through the metal block. This is a solid object, so there is no convection. The metal contracts slightly. No, the temperature increases means that the volume should increase. Thermal expansion, not contraction. So the answer is A. Question 16 says a fixed mass of gas is contained within a sealed syringe at pressure 100 kilopascal. The plunger is slowly moved until the pressure is 80 kilopascals. The final volume is 50 centimeter cubed. The temperature of the gas does not change. What is the volume of the gas before the plunger is moved? We can use P1V1 is equal to P2V2, or we use PV is equal constant. So the first pressure is 100, the first volume is unknown, the final pressure is 80, the final volume is 50. So we divide by 100 on the right side. That gives an answer of 40 centimeter cubed. Question 17 says the diagram shows the more energetic molecules escaping from the surface of a liquid. What is the process called? This is called evaporation. Question 18 says a hot object emits thermal radiation. Which row describes two changes that both reduce the rate of emission of radiation? So reducing the rate of emission means that the surface area decreases and the surface temperature also decreases. So the answer here is D. Question 19 says the frequency of a wave is doubled. The speed of the wave does not change. What happens to the wavelength of the wave? So according to the speed is equal to wavelength times frequency if the speed does not change. When the frequency is doubled, the wavelength is halved. So the answer here is D. Question 20 says which statement about ultrasound is correct? It has higher frequency than audible sound. Yes, not lower. And it is a longitudinal wave or transverse. It is not transverse, it is longitudinal. So the answer here is A. Question 21 says which statement about the image produced by a plane mirror is not correct? The image is real. No. The image is upright. Yes. The image is the same size as the object. Yes. The distance from the image to the mirror is the same distance from the object to the mirror. Yes also. So the only one not correct is A. Question 22 says a ray of light is incident on a boundary between air and water. Under which conditions the ray of light is totally internally reflected? So total internal reflection happens only when we are moving from a denser medium to a less dense medium. So initially in air, no. Initially in water, yes. And the ray is incident on water-air boundary at an angle of incidence, any angle of incidence, or greater than the critical angle. It should be greater than the critical angle. So the answer here is D. Question 23 says a converging lens is used to make an image on a screen. Which type of image is formed on the screen? So since it is formed on a screen, it is a real image, not a virtual image. And for a converging lens, the real image is always inverted, not upright. So the answer here is A. Question 24 says a negatively charged rod is brought near to a metasphere. A positive charge develops on the surface of the metasphere closest to the negatively charged rod. Why is this? Electrons in the sphere are attracted by the negatively charged rod. No, electrons should be repelled. Electrons in the sphere are repelled by the negatively charged rod. Yes. Positive charges do not move, so it is not C nor D. So the answer here is B. Question 25 says the electromotive force of the cell is defined in terms of which quantities? Electromotive force is the energy supplied per unit charge. So the energy transferred by the cell in moving charge around the circuit, or energy moving voltage. No, it is charge. And it is not the power, it is the energy. So the answer here is A. Question 26 says a resistor of resistance R is connected to a battery of electromotive force V. There is a current I in the resistor. Power P is dissipated by the resistor in time T. The energy transferred is E. Which is the correct equation? We should remember this. Energy is equal to IVT or VIT. So the answer here is A. Question 27 says a copper wire of length 80 centimeters and cross-section area 0.20 millimeters squared has a resistance R. Which length of copper wire of cross-section area 0.40 millimeters squared has a resistance also R? So from 0.2 millimeters squared to 0.4 millimeters squared, the area was multiplied by 2. That means that the resistance was divided by 2. To return the resistance to its original value, we should multiply the resistance by 2 to cancel this effect. And this happens when the length is multiplied by 2. So 80 multiplied by 2, that gives an answer of 160. Question 28 says 4 identical resistors are connected to a battery as shown. Each resistor has a value of 120 ohms. Resistor 4 is removed. Which effect does removing this resistor have on the effective resistance of the circuit? So when you remove something in parallel, the total resistance of the circuit increases. So we see the choices first. The effective resistance does not change. No, it should increase. The effective resistance decreases. It does not decrease. Effective resistance does not decrease again in D. So the only choice here is increases by 20 ohms. So the answer is C. Question 29 says the resistors in the circuit shown are identical. The reading on the voltmeter V2 is 1.5 volts. The reading on ammeter A2 is 0.50 amperes, and the reading on the ammeter A3 is 0.25 amperes. So we have here 1.5 volts, 0.25 ampere, 0.50 amperes. What are the readings on ammeter A1 and voltmeter V1? First, the current here should be divided across the two branches. So the total current in A1 should be the sum of 0.5 and 0.25. That gives 0.75 ampere. As for the voltage, since these two resistors are identical, if this takes 1.5 volts, this should also take 1.5 volts in series, since they have the same resistance and same current in series. So they have the same voltage. But in series, the voltage is added, so 1.5 plus 1.5, that gives a total of 3 volts in this branch. So this branch also takes 3 volts, and the supply is also 3 volts. So the answer here is D. Question 30 says a wire is moved in the region between the poles of a magnet. A current is induced in the wire. In which direction is the wire moved? So since we have an induced current here, we use the right hand rule, pointing with the index finger in the direction of the magnetic field from north to south, and the middle finger is in the direction of the induced current. The thumb here is pointing into the page or towards the inside of the page. So it is not toward the S or N pole, it is not parallel to the magnetic field, it should be perpendicular to the field and to the current, and it is into the plane of the paper, so the answer here is C. Question 31 says a fixed resistor is connected to the secondary coil of a step-down transformer. The transformer is 100% efficient. The variable resistor is adjusted so that the current in the fixed resistor decreases by 0.25 amperes. What is the change in the current in the primary coil? Since the ratio of the number of turns of coil on the secondary and primary does not change, therefore the voltages should not change also. And we have a 100% efficient transformer, which means VI, which is the power input, is equal to the power output, primary is equal to secondary. And for the same voltages, if the current on one side decreases, the current on the other side should also decrease to keep the equal sign here. But we have different currents. For a step-down transformer, the current in the secondary coil is greater than the current in the primary coil. So if the current decreases on the secondary coil by half, for example, the primary also decreases by half, by the same factor, but half of a smaller value is a smaller value. So the current on the primary coil is less than the secondary, so it decreases by a smaller number. It is the same fraction, same factor, but in general smaller number. For example, half 8 is 4 and half 2 is 1. So from 8 to 4 you decrease by 4, from 2 to 1 you decrease by 1, so it decreases by less than 0.25 amperes. So the answer is B. Question 32 says an electric device changes the voltage of an electric supply from 240 volts to 20 volts AC. So from AC to AC, but only change the voltage. That is not a generator, not a relay. It is a step-down transformer, and it is not a voltmeter. This only measures voltage. Question 33 says an AC generator is set up so that its coil of wire is perpendicular to the magnetic field. The coil of wire is rotated slowly to produce an alternating electromotive force. A graph of the induced EMF against time is plotted as the coil rotates. Which section of the graph represents a rotation of 3/4 of a turn? So if we start at O, we go 1/4, 1/4, 3/4. So it's from O to R. We check the answers here. We have O to R at C. Question 34 says a uranium nucleus decays to form thorium by emitting an alpha particle. Thorium decays to protactinium by emitting a beta particle. Which row gives the atomic number and mass number of this isotope of protactinium? So first, the nucleon number due to the alpha particles decreases by 4, so from 238 to 234, and the beta particle does not affect the nucleon number. As for the proton number here, the alpha decreases it by 2, so from 92 to 90, but the beta particle increases the proton number by 1, so from 90 to 91. So the answer here is C. Question 35 says which row shows what happens when a nucleus decays by emitting a beta particle? The change in the nucleus, is it a neutron changes to a proton and an electron, or a proton changes into a neutron and an electron? The first two are correct, so it's not C nor D. And the particle of a beta particle is an electron, not a proton. So the answer here is A. Question 36 says, which precaution does not always reduce a scientist's exposure when working with sources of ionizing radiation, ensuring the scientist only works with sources of radiation that have long lives? No, not necessarily. Increasing the distance between the scientist and the source of radiation? Yes, works. Limiting the time of exposure? Yes. Placing a lead shield between the scientist and the source of radiation? Yes. So the only one that is not always effective is A. Question 37 says a detector is placed near a radioactive isotope and records a count rate of 700 counts per minute. The half-life of the isotope is 8 minutes. The average background rate is 60 counts per minute. What is the count rate measured by the detector after 16 minutes? So 16 minutes makes 2 half-lives, and the initial value is the 700 minus the background, because the background does not have a half-life. That gives an answer of 640. And we have 2 half-lives, so we divide by 2 twice. First time is 320, and the second time is 160. But this is only due to the source, not the detected count rate. The detected count rate would also include a background, so we add the background to 160. That gives an answer of 220 counts per minute, so the answer here is D. Question 38 says the nucleus of an isotope of nitrogen N absorbs a neutron. It then decays into an isotope of carbon C and emits X as a particle. What is X? So we balance the numbers of the equation. We have 1 plus 14, that's 15. So 14 plus 1 to give 15. 0 plus 7, that's 7. So 6 plus 1 to get 7. This is the symbol for a proton, which has a proton number 1 and nucleon number 1. Question 39 says the graph shows how the strength of the Earth's gravitational field varies as the distance from the Earth's surface increases. We have a decreasing value for strength with distance, which row describes the effect that this has on the mass and on the weight of an object as it is moved further away from the Earth's surface. The mass does not change, but the weight depends on g. The weight is equal to mg, and g is decreasing, so the weight also decreases. So the answer here is C. Question 40 says a student plots a graph of the speed of different galaxies moving away from the Earth against their distance from the Earth. Using the best straight line shown on the graph, what is the value of the Hubble constant? So the Hubble constant is equal to the speed of recession over distance, which is approximately equal to the gradient of this graph, which is change in speed over change in distance. We can use this point here, 0 and 0, and this point here, which makes a good intersection with the graph, to calculate the gradient. We have 20 million minus 0, y2 minus y1, over 1 minus 0 times 10 to the power of 25. That gives an answer of 2 times 10 to the power of negative 18 per second. So the answer here is A. So this was the end of the exam. I hope you enjoyed this video and found it useful. Keep practicing, and I will see you in another video.